Hey guys, Angel here. And Alex, Ryan, and I have been very grateful for the positive feedback that we've been receiving from you. We just do want to give you a reminder that we are open to any constructive criticism and any comments, and that's the only way that we can get better and accommodate you guys. So let's go ahead and start looking at question 1 for your Chapter 5 PQ. And that it asks, which of the following compounds has no stereoisomers? So an important thing to know before you start this question is what is a stereoisomer? So I've got some definitions down here for you. And an isomer in general is just a different compound with the same molecular formula. So we've already ran into this with structural isomers. So compounds that have the same molecular formula but are arranged differently. But a stereoisomer are isomers that differ only in how their atoms are orientated in space. And so we're going to go ahead and just draw out these compounds here and see where we run into stereoisomers, and the answer that does not have any stereoisomers is going to be the correct answer. So let's go ahead and draw 1,2-dichlorobutane. Got our chlorine and our chlorine. So there's our 1,2-dichlorobutane. Now, for something to constitute a stereoisomer, it must be able to be orientated differently in space. So that's where we're going to run into chirocarbons. Chirocarbons are able to orientate themselves differently in space because they have four things connected to them, four different things, I should say, connected to them, and allow for different orientations when they have that. So here would be an example. Let's say if we had a carbon here, and then it would have two R groups, two different R groups, and then we had an A compound and a B compound, or an A element and a B element. Now, that would be one of its orientations, where you can create a second orientation simply by switching those guys around. And so that's where we start running to R and S conformations, and you guys should be learning that in this chapter. And in natural products, such as natural drugs, the R and S conformations or different orientations have a significant difference on how they interact in the body. And so that's why stereoisomers are very important, even though it's technically the same compound, they're just orientated differently. So going back to the problem, does 1,2-dichlorobutane contain a stereoisomer? And so to draw these more specifically, one of these, that chlorine we could draw as a wedge, while that hydrogen we can draw as a dash, or going away from you. And these actually can be oriented differently because here that makes that carbon a chirocarbon. We have a CH2Cl over on our left side. We've got a CH2C on our right side, and then we have two different compounds here. And so that allows us to orientate this differently because we could put the hydrogen as coming towards us and the chlorine is going away from us. And so that would make that a stereoisomer. Okay. So, and then that's how we would look at the remaining possible answers. So for 2,3-dichlorobutane, we actually have two chirocarbons. We've got this carbon here attached to a chlorine, a hydrogen, and then two different R compounds. And they don't necessarily have to be R compounds. This could be a oxygen, and this could be a carbon, and that would still make that a chirocarbon. However, so that would remove that as a possible answer. And then we actually also have another stereoisomer here at this carbon. So now let's take a look at option C. So 1,3-dichlorobutane. And then here we don't have, here we don't have a we don't have stereoisometry because that is not a chirocarbon. That is not a chirocarbon. You can convince yourself of that because you could put a hydrogen going out, and then let's say we put another hydrogen, my apologies, this would be a hydrogen going away, and this would be our hydrogen going out. And so if we were to flip those two compounds, you'd still have just two hydrogens, one going away, one going out, so that would not be stereoisometric. Whereas this other chlorine, position 3, that would be a stereoisomer because you could have that chlorine going away and then the hydrogen, that chlorine going towards you, the hydrogen going away. You can flip-flop those, and those would be different orientations in space. So that would be our stereoisometry. So that also is not a answer. So that just leaves D. And so let's just double check our answer here. 1,4-dichlorobutane. So we just went over in this last problem how the first position is not stereoisometric because you have those two hydrogens. And so even when you interconvert those two hydrogens on their position, it's still the same orientation in space. You still have one hydrogen going away or towards and the other hydrogen still going away or towards. So therefore, our answer would be